Alright, class, it's time to take a pop quiz. Please put your pencils in writing positions.
Oh, I gotta get out of here. Excuse me, teacher. May I please take a breather?
Alright, Adam, but you better come back before the quiz is over. You don't want to get a 0, do you? Adam! Psst! Adam!
Huh?
Welcome to Science World, Adam.
What? Why am I here?
We heard that you weren't doing your homework, Adam. So we thought that you might need a more direct encounter with the wonders of science.
I think I hear my mom calling me home. I should really be leaving.
But you are home, Adam. Science is your home now. Let's get started, shall we?
But...
No buts. Adam, today you will be learning about stereochemistry.
Stereochemistry?
No, how can I explain this? Stereochemistry is the concept that certain molecules can have non-superposable mirror images of each other. Let's take carbon, for example. As you know, carbon is the basic building block of organic molecules and almost always forms 4 bonds with other groups of atoms. These groups are called substituents. However, the key is that it forms these bonds to 4 different substituents. Notice how in this example, all of the substituents are different from each other. Under most circumstances, a carbon atom that is connected to 4 different substituents is referred to as a stereocenter.
Whoa.
Don't touch that. When these substituents are all different, the molecule can have a mirror image that can't be superposed onto itself. Notice how the red and blue substituents match, but the green and yellow substituents do not. These 2 different molecules are referred to as enantiomers of each other. Notice that no matter how we try to rotate the mirror image, it is never the same as the original molecule. As a result, these molecules cannot be superposed. Molecules can even have more than one stereocenter. In general, a molecule with n stereocenters can exist in 2 to the n different configurations. For example, a molecule with 7 stereocenters could have as many as 128 different configurations. Wow, science! Pay attention, Adam. Stereochemistry is important because our bodies will usually interact with 2 enantiomers of a molecule differently, despite them looking nearly identical. Sometimes these differences can be dramatic.
Oh, I see. So it's like they have an evil twin.
Not exactly, Adam. Sometimes the enantiomer doesn't have a malignant effect.
So why does it matter then?
Well, Adam, there are several reasons. And one of the most important reasons is when the enantiomer does have a malignant effect. One of the most infamous disasters in prescription drug history is attributed to a lack of understanding of the potential consequences that taking different enantiomers can have. I'm talking, of course, about thalidomide. Thalidomide was a drug which was first developed in the 1950s to treat morning sickness. However, it was also found to be useful in treating certain leukemias and leprosy.
Leprosy?
Yes, thalidomide was found to be an effective drug. However, it was originally sold as an equal mixture of both enantiomers. It was later discovered that only one of the enantiomers was the active form of the drug. The other enantiomer was teratogenic and caused severe birth defects. Here's just a few more examples to show you the variety of effects that enantiomers can have. Ethambutol is a drug that is used to treat tuberculosis, but its mirror image causes blindness. Naproxen, found in Aleve, is an analgesic, but its mirror image causes liver toxicity. And one enantiomer of Carvone smells like spearmint, while its mirror image smells like caraway seeds.
But why do I have to learn about stereochemistry? It sounds like people have got everything under control since that thalidomide what's-it scare.
Okay, Adam, here's some motivation. I've just afflicted you with yamacillimatosis, and you're going to have to correctly identify some enantiomers for me before I cure you.
Ah!
This is the reference molecule. Out of the following molecules, I want you to identify which is the same as the reference molecule, and which one is the mirror image.
What?
Yes, Adam. Stereochemistry is important, and you had to learn the hard way.
Which one's which? Neither of them look like the reference molecule. Everything's scrambled up. Wait, that's it. I just gotta rotate the molecules. No matter how I rotate this one, it sure isn't super possible to make it superposable with the reference molecule. That one has to be the mirror image. And just to double check, if I rotate the other one like this, yes, it's the same.
Good job, Adam. You got it. By the way, you were never actually afflicted with any disease. I was just kidding. But now what you are afflicted with is knowledge.
What?
By the way, Adam, you have 5 minutes left on your test.
Huh?